This is a video on beats, which is part of Module 3, Waves and Thermodynamics, part of the Year 11 Physics course. So suppose you've got two sound waves. So suppose you've got a sound wave here with some frequency, let's call it f sub 1, and another sound wave with a slightly different frequency. Let's call that f sub 2. Now in physics, beats refer to a phenomenon when two sound waves with slightly different frequencies overlap or superimpose, okay, if you were to add them up somehow. Okay, and what you get is what's called a beats frequency. Which is basically the frequency at which the intensity or the loudness of the resulting wave alternates between maximum and minimum. And what I should note here is that this is slightly misleading, this picture here, of the two sound waves, because sound isn't a transverse wave, it's a longitudinal wave. But I've just drawn these two sound waves as transverse waves just to make things easier to visualize. So let's suppose in this case I have these two sound waves. Let's call this sound wave 1, sound wave 2. If I was to superimpose them or make them overlap, add them up, I'll get something which looks like this. Okay, let's say, for example, something like this. Probably drawn too many peaks. 1, 2, 3, let's say 4, something like that. Whereby the high intensity sound is depicted as high amplitude peaks, high amplitude waves. Low intensity sound is represented by small amplitude. Right. And there'll be regions where you'll get cancellations for the two waves in terms of you get constructive interference and destructive interference. So constructive interference occurs when two peaks overlap and they add to give you a bigger peak. Destructive interference is when you've got a peak and a trough, okay, and they cancel out to give you nothing. Okay, so that's what happens when you have, let's say, two speakers and you point them towards one another. You'll get beats. Okay, so visually that's what beats frequency looks like. Okay, it's just a wave alternates between maximum and minimum. A really good application of beats frequency is in aircraft. So if you've ever been on an airplane, just so as the aircraft is being pushed back, you'll typically hear one engine followed by another engine starting up. That's a great example of beats frequency because you've got sound waves coming from each engine. And so I've got a nice audio, part of an audio audio file of a Boeing 737-800 engine. It's called an engine spool up. So you can hear the engines sort of out of sync as they start up, and then they'll kick in with the beats frequency afterwards. So here's the audio. And so initially you hear these two out of sync sound waves from the engines, and then eventually they'll sort of combine into this beats frequency, this resulting wave. A good example there of beats. There's a simple formula for beats frequency, simple mathematical relationship. So to find the beats frequency, you simply take the absolute value of the frequency of the first sound wave and subtract it from, you subtract the frequency of the second sound wave from the first sound wave and take the absolute value. You get this formula here. Okay, why the absolute value? Well, because you can't have something like negative frequency. Okay, it's same thing with distance. You can't have negative distance. It doesn't make sense in physical terms. So the absolute value there is just to make sure that what comes out is a positive number. So let's suppose you've got one wave. So one wave has frequency of 400 hertz and another has a frequency of 405 hertz. Okay, what's the beats frequency in this case? Let's work it out. So we use that formula at the top there. F sub beats is equal to, so F sub 1, we use that as 400 hertz. Minus F sub 2, we'll just use that as 405 hertz. Take the absolute value. So 400 minus 405, that's minus 5 hertz. But we're taking the absolute value, so we'll get 5 hertz. Okay, that's the resultant frequency that you get. Okay, so absolute value means make something positive. Okay, or in other words, how far something is away from 0. Okay, which in this case is 5. So minus 5 is 5 units away from 0. Let's do another example. Suppose we know what the beats frequency is for 2 waves. Let's suppose it's 3 hertz. And we know what F sub 1 is, what the frequency of the first wave is. Let's say it's 560 hertz. We need to work out what the frequency of the second wave is. How do we do that? Well, let's start off with the formula. F sub beats is just absolute value of the frequency of the first wave minus frequency of the second wave. Let's plug in what we know. So we know what the beats frequency is. It's 3 hertz. We know what F1 is. That's 560 hertz. But we don't know what F2 is. What do we do here? Well, so in maths, if you have something like this with an absolute value on one side, you can just do this, plus or minus 3 hertz. Okay, the absolute value goes away. I'll show you why this makes sense in just a second. We get this. So let's take that 560 over. So we get plus or minus 3 hertz minus 560 hertz is equal to minus F sub 2. So we get 2 possible solutions here. Okay, plus or minus, that's what that means. Let's start off with the plus case. So plus 3 hertz minus 560 hertz is minus F2. What does that give us? Well, 3 minus 560, that's minus 557 hertz, which is equal to minus F sub 2. Minuses cancel out, so therefore, one possible solution for F sub 2 is 557 hertz. What about the other solution? Well, minus 3 hertz minus 560 hertz is equal to minus F sub 2. Minus 3 hertz minus 560 hertz, that's minus 563 hertz, is equal to minus F sub 2. Minuses cancel out. And so another possible solution is therefore F sub 2 is equal to 563 hertz. So these are the 2 possible values that F sub 2 can take. And that's how you use the beats formula.